Welcome back. And today we're going to continue our discussion of waves and sound. Today we're going to be focusing on some general properties of waves, and we're going to go back to our picture of a transverse wave that we were looking at last time. Now, if you remember, we ended with the transverse wave by talking about the wavelength or the distance between two consecutive crests. Now, what I want to point out is that would require the horizontal axis to be in the units of distance or meters. Now, in math class, you probably saw sine waves, and when you were seeing from one crest to another, you probably thought of the word period, which we'd use in physics as well. So if we change the axis and the horizontal axis, and instead of making it distance, we make it time, then yes, between two consecutive peaks or two consecutive crests, the amount of time it takes for one wave to pass or for it to go from one crest to the next crest would be called the period, which is again that Greek letter tau. And time is always going to be in seconds. Now, don't forget, when we were talking about period, we always talked about the frequency, which is basically period's cousin. Now, the frequency is the inverse of the period. In other words, that would be the number of waves that pass in a given amount of time. So its units would be 1 over seconds, which is the same thing as seconds to the minus 1, or what we're going to be starting to call them, that unit is officially called a hertz, which is represented by Hz. Okay. Now, when we're talking about distances like wavelength and times like periods, a concept should be coming to mind. Remember, way back in August, we were talking about velocity, and we officially defined velocity, say it with me now, as displacement divided by time. Or in our case, this displacement would be one wavelength, and the time would be one period. So we could represent velocity for a wave as being wavelength over period or lambda over tau. Now, we all know how much everybody loves fractions. And let's rearrange this a little bit because couldn't we say that 1 over tau is just frequency? So, doesn't that mean for a wave, velocity is simply equal to the frequency times the wavelength? Bing, 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 bing! Woohoo! And that is true for every type of wave, no matter what.